Good day, Algebra 2. Today we're going to look at section 13-4, dealing with the topic of compound interest. And our essential question is, how do you model the value of an investment that earns compound interest? And what I'm going to do is we're going to do this in two parts. So this is part one, and we're going to rely upon quite a few formulas. I'll explain it to you as you go along, okay? The first one we're going to look at is what is called compound interest formula based upon annually. Now, to understand compound interest, well, I think the best way to do it is just by examples, okay? I have highlighted the formula that we're going to use, but that really came from the original compound interest formula. All right? Now, I do know this is not on your HD&Cs, so you're going to, this is the main formula for a compound interest formula. The difference from this one and this one is the concept of annually, okay? So here is the compound interest formula. Here's how it works, okay? This is what is the value of our investment based upon a time frame equals the principal, which again, principal is how much money you are borrowing from the bank or how much money you are putting into a savings account or how much money you are investing in some type of a fund. That is the principal, okay? One, and then this is 1 plus R. Now, R is your interest rate. Again, the higher interest rate you have, the better value it is. And your interest rate is the one that will have the percent symbol, and we need to convert interest to a decimal. Okay? Just remember now, percent means per 100. So if you have something at like 25%, that's pretty high. But if you have something like 25%, if you want to put that as a decimal, that's 25 divided by 100, which gives you 0.25. Now the value of N is the number of times interest is compounded. So in other words, and since our problem is doing it annually, this N will be 1. That's why that N is no longer in this part right here, okay? I better show the second one, okay? And the T is the time it takes for it to get to our investment. Now, compound interest, just to understand how it does. Let's say, for example, you put money into a savings account, let's say $400. Over a period of time, your bank is going to add interest to that. And that interest, that principal plus your interest added together gives a new value. And that's why that's the concept of compounding. They get added on to each other. So this one right here we're going to look at is interest compounded annually. So in other words, we're only going to get interest on top of our principal once a year. All right, so that is what we're going to do. So these two formulas, just hang on to them. All right, now the way we're going to do it is we're going to do it graphically. I do believe in the next coming chapters we can do this type of a problem algebraically, but right now we're going to use our calculator. So here is an example. A person is going to invest $3,500 in an account that earns 3% interest annually, and we want to find when the value of this investment reaches $10,000. This is a good thing to know how to do, because if you're going to put money in an investment, you got to be able to know, hey, this is how much money I'm going to get I'm going to accrue at the end of this time. All right, so to do this one, again, letter A is already worked out for you, but again, you probably notice up here they have this diagram. Now we probably did examples like this a long time ago, so I'm going to show you how to do this again. All right. Now to do this one, we have our, again, based upon our given problem, here is our compounded annual interest formula. Setting it up, it looks like this. Again, 1 plus R, well, we know R is 0.03%. I didn't show all that work. They gave it to you, but pretty much we need this equation and this equation to graph into our picture. Again, you see this line right here. That's y equals 10,000. This part of the problem right here, this is your exponential function that has a base of 1.03. Okay? How did they get that? Well, first things first, we already know it's not going to fit in your calculator because these are some huge numbers. So again, what I'm going to do is I'm going to show you calculator window settings. You can change them. So what you do is, well, let me just do this. Let me just show you what it looks like if you were to go ahead without changing the window. So if I go 3,500 parentheses 1.03 parentheses raised to the x, and then y equals 10,000. So if I were to go ahead and graph this problem right now, it's going to take a while. Again, the symbol up here is telling me it's thinking, so give it a minute or two. It's not going to show it. So we have to change our window, okay? Zooming out is not going to be enough. So what we got to do is we got to go and set up the window using these window settings. Now again, it's taking a long time. See, I don't see anywhere on here what I graph. So we have to go and do our window settings. So we go to Window. This is the default setting of your calculator ascribed by the calculator company. What we're going to do is we're going to change those values. So go enter. Don't worry about the first one is shade resolution. We don't need to worry about that one. So the first one is the minimum x value we're going to use. It's -20. That means our minimum x over here to the left of the origin is going to be -20. Maximum is going to be 40. A scale. Again, our calculator is a scale of 1, so it's 1 unit. So in this case, our 1 unit is really going to be 40. All right, y minimum is going to be -100. Y max is going to be 15,000. Now again, the y max, you've got to make sure, going back up to this part right here, see this part of the equation? I got to make sure I have enough numbers, enough y values to handle 10,000. So I just went to 15,000, okay? 15,000, and then my y square to be 100. I just happened to choose this. So go ahead and I hit graph. And now you're going to be able to see, again, my screen's going to be a little bit different than theirs because they have different settings. This right here, the blue that is graphing, that's the y equals 3,500 times 1.03 raised to the x. Then the red line is 10,000. You see that? All right. These are relatively easy problems. It's just setting them up and plug them into the calculator. Now you see where these two equations intersect? That is when the time is going to tell us when this account or this setting or this amount of money you put into the account that earns 3% annual interest will reach 10,000. Okay? Now this one goes back to page 1 of your HDNCs. It's very easy. Go second, trace. You want to hit the number 5 or the one that says intersect. Then you're going to look at your screen. You got a blinking light on the first curve, which is the blue one. You hit enter. Then you get a blinking cursor at the second equation. Now it says we want to make a guess. And now where they intersect based upon the directions here, if you look down below here, they intersect at 35.5. So you see, based upon the example here, it'll take 35.5 years for it to reach $10,000. That's pretty good, all right? So again, if you got a lot of money and you're getting 3% annual interest, I would jump into it. That is pretty much what this section's all about. So let's look at the second one. Okay, a person invests $200 in an account that earns 6.25 or 6.25% annual interest. Find when the value of the investment reaches $5,000. Well, here's the given information. We just plugged it in. I plugged it into the interest compound annual formula. And you're going to see we're going to have our two equations. y equals this one, and y equals 1,000. So if we go back to your calculator, clear out what you already have. So y equals 200, bracket 1.0625, raised to, in this case, and since this is annual, our time is going to be x, and y equals 5,000. Hit graph. Wait till it gets done doing its gyrations. Again, there is the first equation. Now this one's going to be a little bit different because I don't see, if you don't see where they intersect, it's not going to work. So we have to go and change something. So again, here in this case, we'll go and change the window. And what I think I'm going to do is I'm going to change my X scale to be a bigger number. And I'm going to see if that works. The big thing is we just got to change numbers because we got to be able to see where they intersect. So I just changed my X values a little bit differently. It won't change the problem. It's just easier to see the graph. Okay, where is it? There it is. All right. Okay, then we go to second trace, intersect. It's blinking on the first curve, enter it. It's blinking on the second curve, enter it. Now we're ready to guess. Click it again. And then if you look down below, it's 53.09. So again, we found it to take about 53 years, 53.1 years for it to reach $5,000. That is what this section's all about. Now remember, this part right here is compound annually. It's once a year. So stop the video and try the year turn. Again, I pretty much did it for you guys already. I thought about let me just show that one, okay? A person is going to invest $1,000 in an account that earns 5.5% annual interest. Find when the value of the investment is doubled. So in other words, we want to find out when this guy has reached $2,000. All right, so go back to your equation. I did all my math. This is 1 plus my interest rate. Okay, so you see it. It's 1 plus my interest rate, so it's 0.055. So 1 plus that gives me 1.05. So let's clear these. So y equals 1,000, parentheses, 1.055, parentheses, raised to the x power, and 2,000. Graph. Again, I think it'll show in this picture, but again, if it doesn't, you've got to go and change. You may have to change some of your values. So if you did this one, okay, where are you? There he is. All right, when it gets done doing its thinking, second trace, intersect, first curve, second curve, make a guess, and it's going to take 12.94 years. So, okay, and about 12.49 years or 95 years, we'll make it that way. It will take to double your investment. All right, now these deal with the compound annually. The next ones deal with more than once a year. And what I'll probably do is I'll just show a couple of examples and then we'll go to the year turn, okay? All right, so this one deals with this formula right here. We've already covered that. All right, letter A deals with compounded quarterly. That means that's going to happen 4 times a year. So I'll let you look at that one. Same thing again, but the only difference now is in your formula that n becomes 4. And I'm using this formula right here. Here's the compound interest formula. N is going to be 4 because we're dealing with quarterly. Nothing else changes. And I'll let you do this one on your own, okay? Now the next one, a person invests $6,000 in an account that earns 6.25% interest. But this one is compounded semi-annually. Now, semi-annually is twice a year. So we know our principal is 600, our interest rate is 0.0625, and semi-annually means it's going to happen twice a year, usually in the first 6 months and then the last 6 months. Here's the setup. They did it all for us. All we got to do now is this part right here becomes this equation right here. This part right here is this line right here. Where they intersect, that will tell you, in this case, how long it takes to reach $1,700. 16.9 years. All right. Here's what I want you to do. I want you to stop your video. And we're going to do the Your Turn 4. So here's a person who wants to invest $8,000 in an account that earns 6.5% annual interest, but we're going to compound it daily. Find when the value of the investment reaches $20,000. All right, stop the video and work it out. Now you're probably saying, I don't know what compounded daily means. Well, how many days are there in a year? Well, this one is 365 days. So stop the video, plug it in, and do your math. Okay. All right, you're back. I have taken the time and plugged my information in here. We know that our interest rate is 0.065, and we have 365. Now, again, I didn't show this one earlier, so how did they get this number right here? Well, if we know our interest rate is 0.065, so 0.065 divided by 365, we take that value and add 1 to it, and that's where they get 1.000178. Okay, you could probably see it on my calculator. That's your problem. So what you got to go ahead and do now is take this information. Also, now we've got to change our window because our Y is at 20,000. So it's a good idea to change your window to 25,000. Oops, I better do that right. Change it to 25,000. Okay, so Y equals, clear our screen. So we'll have 8,000, parentheses, 1.000178 raised to the 365 to the x power. That's your first equation. And the other one is 20,000. 1, 2, 3. Graph. Let it think. Again, the first graph is the exponential function, and the second one should be y equals 20,000. It should show it here momentarily. Calculator's thinking. There it is. So what we can do now that we found that, where they intersect, that will tell us how long it took to reach $20,000. So second trace, intersect. It's blinking at the first one, so you hit enter. It's blinking at the second function, enter. Now we're ready to guess. It's thinking, so it's going to take 14.1 years to reach $20,000, or reach an investment of reach $20,000. All right, that's how this section's all about. It's just taking the formulas, plugging your information into your formula. Once again, this is the formula we're going to be using in this first video, compound interest formula. Remember now, N is whether it's going to be annually, it's 1, semi-annually, it'll be 2, quarterly, it'll be quarterly is 12 divided by 4. That's 3. It could be monthly. That's 12. You'll be able to see it, okay? This one is relatively easy. Now, again, something else I need to show you. Remember now, if you don't change your calculator window settings, this is what it's going to look like. So if you have to go and do any other review on another assignment or whatever, you've got to go back and change that. Now to change that, okay, the simplest and easiest way of doing it is going ahead and go hit second and all the way here to the plus, second mem, and go ahead and reset your entire calculator to its original defaults and reset it. And now when you reset it, it's going to go all the way back to the factory settings. Okay, that is section 13-4, the first part. Okay, second part comes up next. Catch you later, guys.